We're going to take a look at problem number 17. We're asked to solve, so we need to get x all by itself, and it looks like this is kind of a long problem. We've got some work to do, so let's get started. Let's always start by drawing a line down through the equal sign. That'll separate each side, okay? When I'm looking at a complicated equation to solve, the first thing I do is I look for parentheses. If there's parentheses, we want to take care of that first. So whenever there's a parentheses, we want to do the distributive property. And the distributive property is just a fancy way of saying whatever's right in front of the parentheses, we have to multiply that by each of the things. So 3 times x is 3x. And 3 times 4 is 12. So this is going to become 3x plus 12. Okay? And now let's just write the other side, rewrite the other side. So 4 plus 3x plus 8. Okay, there are no parentheses anymore, so that's a good thing. The next thing we want to do is we want to cover up each side of the equation, and we want to see if there's any like terms that can be combined. So we've got 1, 2, 3 things here, and we notice that this is just a number, this is just a number. Those could be combined. 4 plus 8 is 12, so it would be nicer to just say that there is 12 over here plus 3x. And now let's look at the other side. You'll notice that these are not combinable. This one has an x attached to it, this one doesn't. So since we can't combine them, we'll just copy it down. Okay, so now that we've gotten rid of the parentheses, we got rid of the like terms, the next thing we want to do is we want to ask ourselves, are there x's on each side of the equation? If there are, we want to move one of the piles over. We like to move whichever pile is the smallest, but each of these are 3 x's. So these piles are exactly the same, doesn't matter which one we move. So let's move this one. So the opposite of a plus 3x would be to minus 3x. So we'll do that to both sides. And I think what's going to happen next is going to be rather interesting. So there's a 12 over here, but the 3x minus 3x, they canceled out. So we just left with a 12. And now over here, the same thing happened. 3x minus 3x. These x's go away, and all we're left with is a 12. So for the first time in this problem, we see 12 equals 12. And this is interesting because all of the x's completely vanished. That doesn't happen often, but when it does happen, it means that there are either no solutions or there's infinitely many solutions. So to figure out which one it is, we just have to ask ourselves whether this is true. Is it true that 12 is equal to 12? Is 12 the same as 12? Well, yeah, they're exactly the same. So it is true. So we're not going to say it's no solutions. We're going to say that it has infinitely many solutions. So I'm going to write I for infinitely. I'm going to write M for many. And I'm going to write S for solutions. Infinitely many solutions. And you can always just abbreviate like that too. You don't have to write the whole words out. But that is what a problem looks like when it's infinitely many solutions. You would just have two numbers that are equal to each other, and the x's are totally gone.